So let me explain you the priority queue with example. So let me consider a queue. Okay. So its capacity is 5 in PQ of 5. This is my array name. Okay. Initially, front, rear are initialized to -1 since there are no elements in the queue. So now I try to add one element, that is NQ operation. First element, now front is initialized to 0 and rear increments. If there are no elements in the queue, then my front and rear are initialized to -1. Each time I try to NQ elements, rear is getting incremented, and front at first it gets initialized to 0, right? So what is happening? So front equal rear equals to front is 0. So rear equals to rear plus 1. What is rear? -1 plus 1 equals to 0. So my 10 is being stored at 0th position. This is front. And again, I've seen like this. This is front. I've seen like this. What is the black element? This is rear right now. Okay, now I try to add one more element. So rear equals to rear plus 1 is 0 plus 1 is 1. Front is like that only. It does not change all the time. Only when you try to delete elements, front keep on incrementing. Okay, now rear is incremented. My new element 20 is stored at first position. Now I try to add 30. Now rear equals to 20. Now I try to add one more element. Rear equals to 1 plus 1 equals to 2. My third element is 56. Okay. So 56 is added at second position. Now rear is again incremented to, right? 2. Now again rear equals to 2 plus 1, 3. My element is 15. Okay. So 15 is added at this position. Again you try to add one more element. So 3 plus 1, 4. Again my element is 6. So 6. Here is rear, right? Again I try to NQ elements. But Q is already full. Rear equals to n minus 1, rear equals to 5 minus 1, 0 to 4 index, that is equal to 4. So this is Q overflow. So 4, it is priority queue overflow, right? So this is how you insert elements. This is normal insertion operation. Now we'll see if I asked you to perform ascending priority queue. Okay, so what are my elements? 10, 20, 26, 15, 6. Okay. Now first what you will do is consider A of 0th element as minimum element. Okay. Consider, I hope you have written all this. So let min equals to A of 0, right? 10. Now compare A of min with all other elements in the priority queue. In case if you find any element less than the minimum element, then assign that new minimum element as min. Okay. Now compare min with all other elements. If you find minimum element, if you find any element less than min, okay, then assign that element as min element. If you find any element less than the min element you have considered, now that element less element is there, now you have to assign it as the minimum element. Then you have to continue this operation until you fill the, until you keep traversing the entire queue. Now we'll see the operation. Now 10 is compared with this. So 20 is less than 10. Condition false. So keep incrementing. Now 10 will be compared with 56. 56 is less than 10. Condition false. Again go here. Again 15 is less than 10. Condition false. Again 6 is less than 10. Condition. Now min is 6. So delete 6. Okay. So 6 got deleted. Now the Q is 10, 20, 56. Okay. This is how deletion is performed. Let's continue the operation. Now my elements are 10 is now again 10 equals to min equals to 10. Now again 20 is less than 10. Condition false. Again 10 is compared to 56. So 56 is less than 10. Condition false. Again this is compared. 15 less than 10. Condition false. So what is the final min here? Right, you have to delete this 10. So this got deleted and the elements next to 10 are shifted one. So the elements after 10 are shifted one step to left. Okay, after shifting it became 20, 56, 15. Okay. Right. So after deleting, what happened is, so you have deleted now, the elements are moved here. Okay, these are the positions. Now again, consider this as min element. It should be compared with this 20 plus 56 is less than 20. Condition false, we get 10 is less than 20. Condition true. So it is updated to 10. So updated. Okay. Again. Let's continue. There are only two elements. Basics. Okay. 0, 1. Now let's consider 20 as min. 20 as min. Compare it with 56. 20 is less. So 56 is less than 20. Condition false. So min is not changed. Equals to 20. So now delete 20. Deleted. Right. Now the leftover element is 56. So since there is only one element, so you can delete it there. Right. So this is how you perform priority queue operations. Now after deleting this also, in case if you perform decay operation again, what happens? Priority queue underflow condition. Since this is already front end rear at -1, so you cannot delete from empty queue. So it becomes priority queue underflow. Okay. So this is how you perform priority queue operations. This is what we call it as ascending priority queue.